Thanks for joining me on a deeper adventure into lists. I don't think that you made a mistake by jumping in on this one. I wanted to go over a little bit more on lists than we did in the previous lesson. That said, what we went over in the previous list lesson is enough to get going further in Elixir. But I do think that the information that you'll learn in this presentation will give you a deeper, better understanding of how lists work in Elixir and functional programming in general, and better prepare you for some of the things we'll be learning here soon. So let's jump right in. Now, in review from previously, lists are collections of values of any type. Lists values are not stored in contiguous memory. Each list item points to each subsequent element, and it's always best to put new list items to the front or head of a list. If you've heard the saying, turtles all the way down, that's a list, more or less, except they're not infinite. If you haven't, look it up on Google. You'll find some articles on it. It comes from cosmology, and it's the idea that things that are complex are on top of things that are complex that are on top of things that are uncomplex, and they just continue to go down, just like a stack of turtles. To understand a list, you have to understand a single item of a list. And when you understand the single item of a list, you understand a list. Lists are composed of lists, what we call list of lists. The empty list is the baseline for all other lists, and that's right here denoted by the open square bracket, closed square bracket. That is an empty list. An empty list in Elixir has no head, no tail. The only property it has is that it's an empty list. In fact, you cannot even run most list functions on an empty list. You will get an error. And you'll learn how to filter for those later on, and it won't be a problem at all. A reminder, this pipe symbol right here, that is the cons, or the cons cell. Cons was short for constructor, and we're about to learn quite a bit more about that now. This is a job for cons. Cons cells, historically, they harken back to Lisp programming language, and in Lisp, it was a function called cons that was short for construction. Cons is the basic building block of functional programming lists. Each list node is a cons cell. A cons cell is made of two parts, the car and the coulter. Car is also called the first, and the coulter is called the rest. Car points to the value that the node is holding, and the coulter points to the next cons cell in the list, or the empty list, which in Elixir is just this. Incidentally, in Lisp, it points to nil. So this is the cons cell visualized along with the construction of a list from cons cells. First off, on the top left, we have a cons cell diagram. You can see it's composed of the car cell and the coulter cell. This is a visualization of a single node list from the cons perspective. We have the variable that's pointing to the cons, in this case list 1. This is the car cell, and it's pointing to a value, which is A in this case. And then the coulter cell is pointing to an empty list. So this is a single node. If you looked it up on IEX, you would find a list that just had one item in it, and it would be A. Next, we prepend another list item to the first list item. In this case, the list item is B, and we have the car pointing to the value B, and the coder pointing to the next cons cell, which was the list item A. So we have the variable list2 pointing to the first cons cell, which has the value B, and then we have that cons cell pointing to the next cons cell, which had the value A, and I'm still leaving the variable list1 pointing to it. And then finally, the coder of that second cons cell, the original cons cell, is pointing to an empty list. And I just wanted to make sure we are aware that we could also have just set list2 equal to that new list item and not have a variable pointing to the original list item at all. So here we have list2 bound to the cons of the first list item. And then that cons is bound to the next list item, which is A, with no variable pointing to that second one. And then finally, that cons is pointing to an empty list. All right, so let's give that list an item. So when building lists, consider the nature of cons-based lists. If you think about how they're constructed, with the first item always pointing to the next item, and so on and so forth, then it makes sense why prepend is always preferred over append. And now we'll go through some more practice. First, look over this really quickly before we go into IEX again. And what I've done here is I've written out a list in longhand form, which keeps the cons cells in the definition. So we have my list being an empty list, then we have my list being bound to a list with list item 1 constructed to an empty list, and we have my list being bound to a list with 2 constructed to a list with 1 constructed to an empty list. And I'm not going to read the last one. However, if we look at the final line here, these symbols here end up being exactly equal to these here. This comma ends up being what we call syntactic sugar in Erlang, which replaces the need for the cons operator and the wrapping of the list within the list. 3 pipe list 2 pipe list 1 pipe empty list can be written as simply list 3 comma 2 comma 1. Usually we're going to write this, the item that's on the right hand side. This cons operator becomes much more important when we're doing pattern matching, which is one of the next lessons. So let's go ahead and do this in IEX really quick.